you may have noticed that I wrote down the magnitude with a subscript V. What is that MV meant to be? Well, the original magnitude scale is based on how the eye responds, and the eye doesn't receive light equally at all wavelengths. And our current magnitude scale is based on detecting visible light. And in fact, we narrow it down a little more than that. So MV is the visual magnitude. It's the magnitude as seen in visible light. It's actually slightly more carefully defined than that, and you'll see that as we move on. But it certainly does not account for wavelengths outside of the visible wavelength range. We define these bands, and these bands are often defined to do with how you make a filter. So you can think of it as being, I've got a filter that lets in light that's a visible wavelength, but it's not all visible light. It lets in most light at around green-blue. It lets in a lot less light in yellow, and basically no red. It also doesn't let in much in the way of violet indigo, so you've got some blue and some green and some yellow, and this is the definition of V. So that subscript V is really how bright is it in these wavelengths, and it's even weighted according to having the most at this wavelength and the least at this wavelength. We also have other filters called, so V is for visual, B is for blue, even though it's actually peaking in the violet, and it's giving you some ultraviolet down here, and it's even giving you a tiny bit of green down here, but no yellow or red. And here we've got an ultraviolet band that has a tiny bit of visible, but is mostly ultraviolet. And so, you know, basically different filters will let in different light, but also different detectors will behave differently. So the eye is sensitive to all of these wavelengths, but actually it peaks somewhere around here. It peaks in green, and it's less sensitive to blue and red. Whereas you might be able to tweak a photographic plate according to the chemistry, or a CCD is kind of like the chips that you have in camera phone, where you're sensitive to light. You can tweak them to make them sensitive to the infrared or the ultraviolet, whatever. But so that we know what we're talking about, we define bands, that is, these filters that we're looking in. And so UBV are ultraviolet, blue, and visual, and those are things that can be done from the ground. You can see through the atmosphere at those wavelengths, and they're based on the standard set of filters. You want to know exactly which one of these filters was used. We also have other filters, R for red, I for infrared, the JHK are also infrared, L&M are mid-infrared, and so on. We'll actually have a look at these. So here we can see, so this is also another version of ultraviolet, slightly different. So it's the prime, G is green, R is red, I is infrared, and Z is kind of a mid-infrared. And the primes actually are because they're not quite the same as ones that are also called R, I, and Z. And here you can see this is Z, and it's slightly different to this one. Centered around the same wavelength, but it's slightly different. Then we have J centered at about 1.3, H centered about 1.6, and K at about 2.2 microns. And these are partly to do with the materials we can make, and partly to do with the opacity of the atmosphere. And so here I've got, this is just giving you the central wavelengths, but they also cover large, you know, there's overlap between them. So we have ultraviolet blue, visual, and then these are all infrared, but with increasing wavelengths.